All right, so let's do some actual maths work. I want you guys to work through exercise 105, questions 1 to 3, and then questions 5 and 6. And what we're looking at are mixed Pythagoras questions. So before we kind of get into this, let's have a quick reminder about triangles, because it has been a while since you guys did any of this maths. Something that you may have noticed or we may not have noticed, but it is important in maths, is the fact that in a triangle there is definitely a relationship between the size of this angle here, which we tend to use a capital letter for the angle with a degree symbol. The point is given a capital letter, and the length that is opposite is regularly given the lowercase version of that letter, and of course some units, centimeters. That means if I call this corner B, then this angle in here is B degrees, and this length is lowercase b in centimeters. And of course, if I call this one F, probably call it C though, this angle here is C degrees, capital C, and this is C centimeters, which of course it's a little hard to, the capital C and lowercase c look very similar, but it's all size related, so hopefully you can tell. Um, Now, something that you should notice if I do that, and if I do that here with D and D and E, hang on, capital E I should do, D and D and E and little e and capital F and F, and then here with some more letters, well, what we hopefully will notice is that the biggest side in each of these triangles is opposite the biggest angle. And the smallest side happens to be opposite the smallest angle. It's not just left and right every time. If we've got a triangle like this that's actually an isosceles triangle, well, in this case, we know that these two angles are the same. So what letter am I up to? G. Well, I know that G degrees and G degrees are actually the same size, which is interesting because then G centimeters and G centimeters are also equal. So those equal sides happen to be opposite each other. GH degrees with a lowercase h centimeters. So again though, the smallest side, I'll go purple for smallest again, is opposite the smallest angle. And the biggest side, in this case sides, are opposite the equally biggest angles. There's a tie for biggest, there's a tie for the biggest angles. Now I know many of us talked about this last term, but it's worth remembering. Now that helps us to make sure we're naming the sides in our triangles carefully and using the right symbols for angles, for points, for lengths. This side here technically could be called BC because it goes from B to C. But we talk about its length as being A because when there's only a triangle with no other lines, this A is related to the size of this angle because the biggest ones are opposite, the smallest ones are opposite, and the medium ones, if it's not a tie, are opposite. So Pythagoras' theorem reminded us that if we have a triangle, the hypotenuse is a special name for the side which is opposite the right angle. It is always the longest side in a right angled triangle because the right angle has to be the biggest angle, the side opposite has to be the biggest side. The hypotenuse, which we can call h, and the other two sides which we'll call a and b. Now some formulas use c for this like I did up here. Actually I used a and moved them around, but I think it's easier in that case to call the hypotenuse h, centimeters, centimeters, and centimeters, hopefully. What a guy called Pythagoras realized, if we remember, was that h squared is equal to a squared plus b squared. So Pythagoras' theorem allows us then, if we know we have a right angle and we know two of the sides, any two of the sides, we can find the other one. What we need to work out is, are we trying to find the biggest side or are we trying to find one of the smaller sides here that is next to the right angle, not opposite? In this case, we could say x squared is equal to 4 squared plus 3 squared. And this is the working out you need to use, which is one of the reasons we can't do this exercise online, because you can't type this in and the computer doesn't remember that, well, can't tell whether you're right or wrong if you put spaces in front of the plus and the minus, or if you work out some of the numbers, it gets too lost. So we need to have this on paper. Well, once x squared is equal to this, we can actually just use a calculator. Calculator can tell me that 16 plus 9 is 25. So I know here, and this equals again, and equals following something always just means, and this is equal to what we've got. It's telling me that x squared is equal to 25, but I don't care about x squared. This side can't be 25 centimeters. I want to know just what x is. So the way to undo the squared is we take the square root, as we did back in the other topic. The opposite of squared is square root, and we unsquare 25. What number times by itself is 25? Well, that is 5. And I say x is 5. X is already in centimeters. I don't have to say it's centimeters. Or I could say x centimeters is 5 centimeters if we're going to be precise with our algebra. Now, that we spent a whole lesson just practicing finding the longest side. If we get a question like this where we're finding the shortest side, well, again, we write this is our h, this is our a, this is our b. Doesn't matter which way a and b go, but the h must be the one opposite the right angle. So we go, okay, we know that 20 squared is equal to a squared, so x squared plus 16 squared. Well, now this gets a bit interesting. I can't type this into the calculator yet. I can put pieces into the calculator. Might just stretch this screen a little bit, move that out of the way. I can put 20 squared into the calculator. It gives me 400. I can put 16 squared into the calculator. I believe I get 256. But I don't know what x squared is. Well, here's something that you guys have been doing for ages. If I just pretend this is a box, 400 is something plus 256. Well, the way to work this out is actually to just swap from doing an addition of an unknown number to doing it as a subtraction. We can say this unknown number must be whatever's left over if we take 400 and take away 256. Let's see if I can write properly. So x squared take away is 400 take away 256, which then means, well, now the calculator can really help. Or if you wanted to, you could even do it while it's still squared and say this is 20 squared, take away 16 squared. Doesn't matter. I might just remove that square, the take away, because it made it look like an equals all of a sudden. But 20 squared take away 16 squared leaves us something left over. It leaves us 144. Well, again, if x squared is 144, to just work out x, remember this is different to x squared, it's the unsquared version, we can square root 144, and x is 12. And again, I don't need to write x here, but we tend to because we like it to look nice, but I can leave it like that. Now, this is the working out we should be seeing. If you're finding the longest side, it should probably take you 4 lines of working out. If you're finding a not longest side, it should take you 1, 2, 3, 4, 5 lines of working out. You don't necessarily need to do this bit. Well, you can kind of smush some of that together. It's 5 or 6 lines of working out, depending on how you lay it out. But we need to be showing all of that. So what we're trying to do today then is, well, what if I just give you a random question and I say, well, do it. You can't always add, you can't always subtract. You've got to look at it and work out which one it is. In this case, again, if you think you're confident, you can happily go have a go at those exercises now. If you get stuck, and pause the video and start them. If you get stuck, come back and we'll watch the extra 2 examples. Well, here, again, first thing, which one is the longest side? This one is the hypotenuse. So we know that 10 squared is equal to, y squared plus 7 squared. 10 squared is 100, 7 squared is 49, but we can't do anything with that. To find y squared, we have to unadd 49. Y squared is 100, take away 49. which is 51. Now this is going to get a bit challenging for some of us. Y then must be the square root of 51, but that's not a whole number. That is going to be some ugly decimal. Now some questions will say leave it as a surd. Now because we already did that in the other topic, we know this thing with a square root is called a root. It's also sometimes called a surd, but this can be the answer. We should know that the square root of 51 is a little bit bigger than 49, and we knew 7 squared was 49. This number is going to be 7 and a little bit, but we can leave it like that. If we don't want to leave it like that, we need to actually type this in. We need to go the square root of 51 equals, and it gives us a number. It says 7.1414, 1414, etc., etc., etc. And we should round this off. We just need to pick a decent spot to round off, usually 1 or 2 decimal places, but we would chop it off here and just say that it's approximately 7.1, or y meters in this case is 7.1 meters. How would we do this one? Well, we've got another similar kind of question, and again, I should have had the right angle there. If there's no right angle, you can't do it. I've already called it h. That's easy. H squared is equal to 4 squared plus 4 squared. The calculator can do 4 squared plus 4 squared, or you can do it slowly. 16 and 16 makes 32. If h squared is 32, don't need to write the h squared. I know that h is the square root of 32, and the calculator again is going to help us out. We'll just move it over to the other side this time. What is the square root of 32? It says 5.6568, 5.6568, etc., etc., etc. Again, these are fairly short numbers. I'm going to chop it off there. And whenever we round off, we always look at the next digit. This time it was a 4. It was too small. We didn't care. This 5 is big enough, so it makes us add 1. And we get 5.7, or h centimeters is 5.7 centimeters. That's what we're trying to do. Just write out the formula that we've done for a couple of lessons, or that you can go back and revise, and then put the numbers in that we can, subtract if you have to, take the square root. If it's nice and it's a whole number, beautiful. If it's not, you'll need to round off a decimal. I wonder if anyone actually jumped away before we got to these and then had to come back, because what do you mean as a surd? What do you mean as a decimal? But that's what we're trying to do. I'm really sorry these videos are quite long today, but it's been a while after the holidays, and it's good for me to go through things a little more slowly and make sure we all understand what is going on. So, have a go at the textbook work. As I said, I'm not going to give you any extra work to do on Friday. It is catch this stuff and the previous stuff up today and Friday. My plan, if I can do it, will be to try and offer a slot where we can do a live online thing through Microsoft Teams where people can ask for help. But I haven't been, I'll have to schedule that with my wife so that we don't overlap and crash the internet at my house. We may have to do those of a Thursday as opposed to of a Friday in future weeks, but I will see what I can do, and I will let you know on Google Classroom. So please keep looking on Google Classroom, check your email regularly, and we should all be getting this work done, and it would be great to have all 29 or 30 of you guys working effectively this term.